Assalamualaikum and salam sejahtera. My name is Sharizad Hakim bin Suadi and I will present about my final year project, which is the study of palm oil ester as lubricant based oil. In this presentation, it contains introduction, literature review, problem statement and objective, scope and limitation, methodology, and preliminary result. Nowadays, vegetable oil is widely used in our industry, including in manufacturing, automotive, and other sectors. Unfortunately, in their original form, they have poor performance when exposed to high temperatures and pressures. They may oxidize and suffer chemical and physical compositional changes. Thus, fat and oil are being modified in order to improve their characteristic performance for their functions and applications. Employed modification techniques are fractionation, hydrogenation, and transesterification. Due to the depletion of mineral-based energy resources and the negative impact of the continued use of engine oils derived from fossil fuels, companies have focused more on usage of vegetable-based oil. This oil is renewable and biodegradable, which can greatly reduce pollution. For literature review, several journal and research articles have been studied for this project. First, palm oil as an alternative lubricant. Palm oil, which is a major agricultural product in Malaysia, has the potential to be used as a lubricating oil in the industry. Results by Dandan A and Samyon S in 2017 demonstrate that palm oil has a lower coefficient of friction and a higher degree of lubricant film stability than other oils. However, the low oxidative stability of palm oil prevents it from being employed as a biolubricant in its pure form. Thus, chemical modification of palm oil is required to enhance its performance. Yahya MS and Rauf NA in 2019 studied that modification might help to improve the quality of biolubricant made from palm oil. As a result, it is considered one of the finest alternatives to mineral oil lubricants. Palm ester, which is a product of synthesized fatty acid ester, can be obtained by transesterification. Transesterification can be accomplished in a two-stage acid-alkali catalyzed transesterification method with methanol in the presence of a base catalyst in the first stage and a polyhydric alcohol to produce the equivalent polyol ester in the second stage transesterification. Next, for characteristic of lubricant, they must be able to keep surfaces apart while also protecting them, acting as a cooling fluid and being sufficiently stable. Thus, there are several characteristics for lubricant which include kinematic viscosity, pour point, flash point, oxidation, and thermal stability. The viscosity of a lubricant controls the thickness of the film of oil that forms between two metallic surfaces while they are moving in opposite direction. Next, when evaluating flow qualities at low temperature, the pour point, or the temperature at which a lubricant ceases to flow, is essential to determine and understand. Next, by Kanna R. Purusottam T. Srirat KS in 2017, the flash point of a volatile substance is the lowest temperature at which vapor of the material will ignite. It is necessary in safety of handling and shipping lubricant. The oxidation stability of oils is critical in defining their quality, which was described as an oil to oxidation with air by Dwivedi G in 2014. Next, the important characteristic of lubricant is thermal stability by Fitch EC in 2019. Thermal stability refers to a fluid's capacity to withstand decomposition caused by temperature changes. It sets the maximum operating temperature for lubricant can be used before causing failure. Next, the extreme pressure qualities are required for use in certain applications that may encounter significant loading or shock in lubrication. By Noria Corporation in 2019, anti-wear qualities are required to prevent machine components from wear and metal loss under boundary lubrication conditions. They are activated when they come into contact with heat, forming a coating that reduces wear. For problem statement for this project, the world now relies heavily on petroleum-based product, which could be one reason of environment pollution. It is also a finite resource which will eventually run out in future. The palm ester, which potential to replace current base oil, have less research on its properties and ability, which lead to fewer products optimizing palm ester oil. Thus, this study aims to identify characteristic behavior for different palm ester oils and then to compare the characteristic of palm oils to base oil. The third objective of this project is to determine the wear preventive characteristic and extreme pressure properties of palm ester oils by 4-ball tester. For scope for this project is the parameter are kinematic viscosity, pour point, flash point, oxidation, and thermal stability for comparison of palm ester oil and base oil properties. The tribology test of the palm ester will focus on wear preventive performance and extreme pressure properties by using 4-ball tester. The limitation for this research is there has been a limited research into palm ester oil, which caused the less reference for this study. And next, since this is a laboratory research, the student need to queue for using laboratory equipment, which may cause to delay of project. For methodology of this project, there are several types of tests that will be done. First, for kinematic viscosity, overloader type viscometer will be used along with temperature bath to regulate the required temperature for measurement, which following a STM D445, the efflux time taken for 3 times and averaging the result. For the pour point test, a cloud and a pour point machine will be used according to a STM D97. The pour point is calculated when the oil shows no movement when held horizontally for 5 seconds. In flashpoint test conforming to ASTM D92, a Cleveland open cup tester will be used. It is measured when small test flame passing over the surface of the liquid causes the vapor to ignite a flash. For measuring oxidation stability, the racemic test method will be used, with function by accelerates aging. The time until an electrical conductivity of specimen be seen is called induction time, which be used to calculate the oxidation stability. Next, a thermogravimetric analyzer is used to determine thermal stability according to STM E2550 standard as the temperature reached at which a material begins to decompose. For wear preventive characteristics by 4-ball machine, the upper ball, which is held in place by the rotating spindle, rotated in opposition to the 3 balls that were placed into the ball pot. The load is applied under specified condition testing accordance to ASTM D4172. The wear scar diameter on balls will be measured. While for extreme pressure test, the same machine will be used as wear preventive test, but under different test conditions according to STM D2783. The load start at low load and raise every 10 seconds until the lubrication fails, indicating that the ball have become permanently bond to one another. For preliminary result, the kinematic viscosity test for pump ester 2088 and 3971 has been done. It shows the difference in thickness of these two pump ester. The pour point for each pump ester will be measured through their solidification point from pour point test. The flash point, oxidation, and thermal stability for each pump ester will be analyzed through the mentioned method. This behavior characteristic will be compared with base oil analysis. In the wear preventive test by 4-ball tester, the wear scar diameter and coefficient of friction of steel ball surface will be analyzed through optical digital microscope, while in extreme pressure test, the wear scar diameter and the maximum load of the oil can maintain its properties before seizure will be measured. Thank you.